Don. Yeah, so I will just a little about me. I've been doing this kind of work for the last 15 years or so, and I'm an engineer with an MBA who is just interested in making the grid more reliable, and this the program that we run here rewards folks for basically helping their community, and that kind of has a good kind of karma feel to it. So I want to stress Don's comment, which was, if you have any questions, please put them in there. I come from a big family, and around our dinner table there'd be 3 or 4 different conversations going on at the same time. So happy to take your thoughts and integrate them into this as we move forward. So what I want to cover today is just start with a high view of the electric grid, and then go and hit how demand management programs can be used to help the grid and compensate sites like yours, and then how we specifically apply this at hospital sites. At the end, we'll have some question to open it up, and we'll have, if you want to talk about anything broader than that, we can do that too. So I think a good place to start is, where does our power come from? And the backgrounds that you all have are such that I believe your answers to this question would be a lot more knowledgeable than that of a typical American. But I will tell you that there was a survey conducted years ago that said that that had 35% of the respondents, when asked this question, said, anyone want to guess? Our power comes from the outlet, which is kind of painful to think about. We think about this. A lot of folks, think about power as just this unlimited resource that you plug in, and it gets supplied to us in the level we need. Maybe it's a good thing, right? Maybe it shows that normally our grid is so reliable that we can depend on it, not have to worry about what's behind it. But in reality, this is a picture of the grid as it's operated for most of its history, and as it, for the most part, operates today. A site with power generation, and that could be coal or nuclear or natural gas, hydro, solar, but that generating site produces power, and it pushes it out to the grid at whatever level it's producing, large transmission lines, substations to distribution lines, and then all sorts of entities use it, factories and offices and homes. Whatever power in this setup, whatever power is not used, is immediately wasted. It evaporates, it's gone. So there's a cost in overproducing, and there's an even larger cost in underproducing. But in the system here, there's no signals, there's no, you pump the power out, you tend to overproduce so that you don't have to have outages, and the power does what it does. So as the grid moves forward, we're trying to integrate things into this where the grid will vary the amount of power supplied based on the amount of power that's needed through forecasts, through smart meters, through communications to and from power using sites and power producing sites. And as we do that, we not only want to be able to alter the amount of power that's supplied, but the amount of power that's used. So for a variety of reasons, you might want to, you might be able to reduce your power at times when it's in short supply, and that will help equally in a kilowatt basis to any power that's produced. Bear with me a moment here. So we need to balance supply and demand. And as I mentioned, any oversupply is waste, thus inefficiency, higher cost, essentially. Anytime we have too much demand, where demand exceeds supply, there will be a blackout. So keeping these in balance is critical. So it's funny, I showed this slide to a younger colleague and they said, well, why doesn't that look sharp? And didn't realize that a chalkboard was such a old idea. But anyway, maybe it's just I'm old. But I remember in economics classes this chart being put up, right? Supply and demand and where they meet. And so not only do we have a balance of supply and demand from the standpoint of we need that balance to make sure we don't we don't have an outage, but as if we oversupply power, if we undersupply power, that is, and we don't have enough, and we have more demand than that, the price of power will go up. So this isn't just an outage issue, it's also a function of the cost we pay. Okay, so what role does CPower play? The CPower is a company I work for, and it is the letter C with a power, not SEA power. We help the grid, not make boat engines. But what we do is we maximize the value of our customers' electricity loads, facility assets, and distributed energy resources, common acronym out there, DERs, and help them save on energy costs in doing so. So CPower, our role in this is to guide our partners and our energy users on how to manage their distributed energy resources to strengthen the grid when there's a need. And that need can be driven based on, again, a possible outage. It can be driven based on economics. It can be driven on other ancillary type needs. So we have technologies that help to facilitate this and make this readily work so that the participants, really all they have to worry about is if I get signaled, I can take action and run my curtailment plan or my reduced power from the grid plan. So we are running across our company and all our customer sites 6.3 gigawatts of DER capacity. We do this, across the country in any area where there's programs for it, or any way we can create our own programs for it. We are, at this point, by far the largest provider of this type of service. 17,000 sites across the U.S. We're the combination of many companies who were doing this before, and that history stretches back more than 20 years, which in this industry is, there really you didn't have something of this type much before 20 years ago. So let's go to the next slide here. So when I'm talking about a curtailment, what I'm talking about is something on a site basis that's represented in the graph shown here. So this is, and I hope you can see the arrow that I'm pointing at this. This is the power usage at a given site, okay? And this is the baseline for this program that they're using to measure against, which is usually driven based on the peak or the seasonal peak for that area, for that site at that time. And then this lower line is the expectation for what level the site will reduce its power to. So what happens here is there's a dispatch, there's an event, there's a demand response event between 2 p.m. and 3 p.m. on a given day. And the site is signaled for that probably at this point at 11 a.m. in this situation. And so they work to reduce their power so that they're ready to go between the dispatched hour. And after that event ends, they start to return to normal. In this case, they didn't need to go all the way back to their previous peak, but they did increase power afterwards. So this reduction from the baseline to the level they need to attain is essentially their enrollment, their expectation from the grid of how much power they'll reduce. And in this case, they fully met that. So just take a peek here. Any questions? Feel free to type them in if you have them, but I'll keep rolling along if you don't. Okay, so we had a significant event recently on December 23rd and 24th. There was this winter storm Elliott affected most of the northeast part of the country, including the PJM grid, which runs from New Jersey out to Chicago down to Virginia. PJM is, by the way, the largest grid in the country in power consumed and power purchased. I believe it's also the largest grid in the world by those metrics as well. So because of the storm, there were power producers, typically sites that were combustion sites that couldn't operate. They, couldn't turn on a natural gas peaking power plant, or they couldn't sustain operations at a coal plant because of the extreme weather conditions. So when you combine that with the extreme cold, there's a lot of sites that use electric heat. If you think of, I know many of you are in the Chicago area, so if you think of a lot of the tall buildings downtown Chicago, tough to heat them with natural gas. So, a lot of those are electric heat, and they use considerably more power in a very cold weather event. So you had this combination of lots of power being used with the cold temps with an outage of regular supply. So what the grid did is it said, hey, we can't get enough supply, and there is demand that will exceed that supply unless we take action. So therefore, we will issue an emergency event and ask our set of enrolled sites to reduce their power. And in doing so, we'll balance that supply versus demand. And it worked. In so doing, the grid had to pay out a lot of money, and the customers who were participating in this got a big Christmas bonus because there's a secondary payment from these programs based on actual dispatch hours. It was the first time in the history of the PJM program that any site was dispatched in the ComEd, Chicago metropolitan area on a mandatory basis. Had never happened before. Okay, so the scenario I just gave you, and most of what I've kind of talked about loosely is the emergency program. So the emergency program is a program in which I'm going to go back to that slide, in which we will have a blackout if no action is taken. And by taking action, we can prevent a blackout. Very unusual for this to happen, but when it happens, it's very critical that action is taken. But there's other drivers for demand response. And what's happened is there's also drivers based on cost. So there's an economic program for demand response. And the economic program, pays more when the volatility of power is high and when the cost of power is high. So due to international events like the war in Ukraine, the price of natural gas went up considerably last year and was spiky and limited last year. Also, we opened up natural gas exporting capabilities, being able to put natural gas in a compressed form onto ships and ship it to Europe. So we had a greater demand for natural gas, and that caused more of a shortage in the United States. I mentioned natural gas because the variable price of electric power is driven by the variable price of natural gas. So as be it natural gas or electricity has volatility, such as a really hot hour in a summer month, this economic program pays a lot. And finally, getting to this chart here, these are typically, prior to the last couple of years, the price of electricity on a given hour was below $50 for almost all hours. But there were, in the last couple of years, there has been greater frequency of volatile hours where that price has spiked to as high as $1,000 or more for a given hour. And so if you think about it from the grid's perspective, they are running a, they are not just responsible for the availability of power and making sure there's no outages, but they're also responsible for making sure it's cost effective. So if they have an hour where the price of electricity is surging and their cost to bring that power in, maybe they buy it from a neighboring grid, if the cost of that was $500 to stay with increments on this list, for them to buy it from New York ISO, for example, they might say, hey, would anyone in the PJM area who's qualified for the economic program like to reduce their power for the same level instead? And I'll give you $250 for that. And if I give you $250, I'm saving the cost of buying it from a more expensive entity. So this is a way where the grid is using the ability to communicate with sites, the ability to reduce power as equal to the ability to produce or import power, to help us all have a lower cost of power. And in so doing, participating sites in this economic program are earning a tremendous amount more in those opportunistic hours they participate in this program. So just for one rough example, I have a customer who participated in this program as much as they possibly could last August. It's a site that is about the size, smaller than some, bigger than others, of a large hospital, but they are not in the hospital industry. And they earned $120,000 in this program in August alone. So it can be, quite lucrative. There's another program beyond the emergency program called synchronized reserves. This is typically not a great fit for hospitals. But I have seen in a couple instances where it did work, so I'll mention it. Synchronized reserves is a program that is run not based on is there going to be an outage or how much it costs, but if there's a disruption on the grid can resolve that with a short term, less than 30 minutes, usually less than 10-minute reduction in power from strategically located sites if they can respond quickly. So if they can respond within essentially 8 minutes, that requires us to automatically dispatch their site and reduce their power. If they can do that, we can moderate grid disruptions and do things like bring hertz and voltage levels back in line when there's been this destabilizing effect on the grid. That's the Sync Reserves program, quick response. So what you can see is over time, in 2019, that program was paying on average for folks who participated every hour, $13,000 to $14,000 per megawatt over the course of the year. Last year, trending from January through September, the program was paying dramatically more, $71,000 per same megawatt. I will tell you that we don't have the numbers here, but the rates for this program did get reduced substantially in the later part of the year. But just another example of market volatility and opportunity for folks who can participate in this program to earn back a significant sum of power if they can meet these requirements. Okay, feel free to type in any questions if you have them. So if we look at these three programs, the capacity performance program, or the emergency capacity program in PJM, this is a minimal effort program. You curtail for a test event once a year, and unless there's a real event, you're done. If there is a real event, you curtail during those hours. And I'll tell you, for a hospital, an extra bonus is that you get a signal saying, hey, you could have a grid disruption. And hospitals typically have at least backup generation on site, that if the grid gets into that condition, they're going to want to know, hey, be ready. You might trip your generators, or you might want to make sure they're prepared and ready to go, because the grid might fail you. If the emergency capacity program, called capacity performance on this slide, gets signaled, we are at risk of an outage somewhere. So our portfolio allows for folks who participate in this program, if you have a higher baseline in the summer versus the winter, we typically have enough other customers who can take that winter load, and we can balance that so that we have a year-round promise and commitment to the grid that can be fulfilled. So CPower has the flexibility to fit in all types of sites into this program. This program is one that requires an annual commitment, and you commit to that no later than May, and then your enrollment starts June 1st, and then you go from June 1st all the way through the end of May the following year. And then for the next year, you can change your enrollment level, but you have a one-year commitment when you're in that. So we next covered the economic program. The economic program is an hourly program. You can choose to opt into this program whenever you want. And typically in this program, what we do is we'd send you a signal the day before and say, hey, there's an opportunity. If you want, tomorrow, it's going to be hot between 3 and 5. And if you can curtail your power for those couple hours, we will pay you X dollars, or usually X tens of thousands of dollars. If you don't want to, no issue. But if you do want to, here's the opportunity. You just have to say yes or no. And if you say yes, you have to fulfill it the next day. Synchronous reserves is that fast response program. So we would be connected to your site and be able to do something, toggle your building management system, turn on a generator, something that gets the response within 8 minutes. And you can opt out for certain hours. You can say, we're only in this program on these hours of the week, or we're opting out tomorrow. But when you're in, you have the potential to get dispatched. Most hours are not dispatched, of course, and you can still earn some money in those hours just by making your site available to the program. I'll tell you, it is odd to have this conversation without feedback, and I don't know if the words I'm saying are making sense, but I hope they are. And but if you have any questions, please do type them in. So there's other programs that we offer too, right? So we just covered capacity performance, we covered economic, we covered sync reserves, which here is called ancillary. There's another program called frequency regulation that pays a multiple, 5 to 10 times what sync reserves pays. This is a program that is only for batteries, pretty much. And if you have a battery you can offer that battery into this program, and when it's charged, and in doing so, you can really pay for, a lot of the way that people use it is to pay for the cost of installing a battery, knowing you can enroll it in this program, after it's installed, is a way to kind of make your business case better to buy a battery in the first place. The last program here is energy efficiency. So we basically, this is a mathematical program. You do a project at your site, and if you curtail your power, if you reduce your permanent load, so let's say you replace fluorescent lights with LEDs. In doing so, you have permanently reduced your facility's peak load on the grid, and we can monetize that and collect money for you. I will tell you that in ComEd, they have an outstanding program, and ComEd is one of the few utilities that actually does this and couples it with a second stream of money. If you get the ComEd money, that's fantastic. It'll be more than we can pay you. We're only pulling from the grid bank. ComEd pulls from an extra fee they have on their bill plus the grid. But if you ever miss out on a ComEd, or if you have facilities that are in Ohio that don't have that kind of program, or other states as well, we can get you energy efficiency credits for those kinds of projects. Peak demand management is a different kind of program, and pretty much not one I would recommend for hospitals. But basically, if you're doing capacity performance, you're pretty much getting the same benefit with less effort than peak demand management would give you. Okay, so I mentioned that the PJM area goes from Chicago out to New Jersey, down to Virginia. This is a map of it. And so again, the programs: capacity performance, sync reserves, economic, frequency regulation. We have, if you're going to be participating in 2 or more of these programs, we have a system that can store a custom algorithm for your site and know your operational limits. We call this Enterwise, and Enterwise can automatically run your site within the parameters you need it to be run. And it will do all of this in an automated way. So let's say we can't dispatch between certain hours, or you have a generator that you use for your dispatches, and you can only run it 100 hours a year. Whatever your constraints may be, Enterwise stores that and forecasts out the market and figures out the best possible hours for you to participate in the best combination of programs, and thus optimizes your return from multiple programs, all in an automated way. This is really, when we talk about the grid getting smarter, and we talk about demand management, this is a real step towards the smart grid. 10 years from now, we'll be talking about this in terms of all of our refrigerators might be connected to the grid, or we'll have more of these capabilities with cheaper controller equipment and more smart grid technology and smart metering, causing us to make it more readily available for us to participate with our homes. But for now, this type of technology is getting used for larger sites and is helping to maximize earnings while having improvements on the grid in capacity assurance, cost effectiveness, and quality of power. So when we do an Enterwise consultation, there's a lot of information we take in to really understand the specifics of that site and what they need. And it's all sorts of stuff like, what kind of baseline do they have? What is their cost for curtailing? So what would the price point be to curtail, so we know to never send you an economic signal if your site, if the economic program wasn't paying as much as your site needs to receive for it to be worthwhile. So we'll have all these parameters so that the system and its algorithm can know when it's best to dispatch your site and when we can optimize your earnings. So these are some examples of enterprise sites, and various industries, right? Crypto mining, vertical farming, and a government site. All of these are operating based on different things, right? Reduction in load, a battery and solar site, or an on-site compliant generator, and using those. We found the right program based on the site operational needs. We found the programs that were the best fit for them, and this combination of programs, we were able to add additional revenue of 40 to 68% for these 3 example customers with this customized enterprise approach. So let's talk about hospitals, specifically hospital power use. So hospitals use about 3 times more power than commercial buildings use. And so that gives a lot of opportunity for, there's different equipment there that, if managed properly or if controls are there, gives more opportunity for a hospital to be able to reduce load and thus participate in the program. Furthermore, the cost of healthcare is increasing, and the jobs that all of you are doing are critical, because 25% or thereabouts of a hospital's cost to operate is now energy related. So the work you're doing to make your hospitals more efficient is saving all of our cost of healthcare. And the programs I'm talking about is just one way to reduce total energy spend or make your sites energy generators. And in this slide, I'm trying to talk about how that could be done based on curtailment activities. So reducing your use of HVAC, or reducing whatever at your site, and I'll tell you, different sites have different plans. Whatever at your site that can safely be done to reduce power is something that gives you an opportunity to participate in these programs. So separate from that, hospitals have another tool that they can use to participate in these programs, and that is that most hospitals are significantly, if not fully, backed up with on-site generation. Now, unfortunately, most generators that are installed, be it hospitals or elsewhere, don't have compliant emissions that are sufficient to participate in these programs. They are essentially backup generators only. They're for emergency use only. However, if the emissions are clean enough, or the generator satisfies, sometimes there's grandfather clauses, or CPower can actually take your generator specifications and review them to see if your generator falls into one of 3 categories. It's not compliant, can never be compliant. It's not compliant, but with an investment could be made compliant, or it's compliant for use today. And if it is compliant, or we can get it to being compliant, all of a sudden, all these things of how will your site be able to perform in these programs becomes a lot easier, because these generators can use can reduce your site's grid demand without impacting your site substantially. You need to run them periodically anyways for their maintenance, and they're a cost at your site that you could earn money back from that and make this more cost effective. So generators, when compliant for use, are a fantastic way for hospitals to participate in this program. And I would say participate in either capacity performance or economic, especially. Okay, that is all the content I have. So I'm interested in any questions you might have, and or how I can best help, or what I might have left out. Don, are you seeing any questions that I'm not seeing?
Not yet, Rocco. I'm actually typing one myself.
Okay. Okay.
Just as you asked me, my phone went off too, so
Yeah.
gone into voicemail. While I'm speaking, can I just ask you?
Please.
I guess I've heard about you and CPower from some of our members. I think you've done some work for their hospitals. Can you apply any of these things today that you covered to any particular project to maybe highlight some ways you were able to really put this thing to work in an ideal situations or whatever, or just
Yeah. So I'd say that the majority of large hospital sites are in a program of this type, and CPower is the provider of this service to most of them. I want to protect the privacy of any customer. Lots of our customers are happy to say that they're with us in the program, but I don't want to divulge that. I will say that of the attendees for this, the people who enrolled for this, many of them are customer sites. For hospitals, currently, especially in the ComEd area, the only program the hospitals are participating in today is the emergency capacity program. I will tell you that we are working with a few hospitals to add on the economic program, and we are working through generator compliance issues and generator permitting issues to make sure that's possible. But we have hospitals participating in this program that are, I would say, in one of three ways. The first way is they have an ability to, you have a huge staff of qualified folks to manage the facility, and they can either manually or semi-automatically reduce power at their site, change settings in the building management system, things like that when called. And that can reduce the power load at a site by as much as 10%. Another opportunity is for if they have the generators that I mentioned near the end. And if they do, they can turn their generator on, transfer load to it, and then you can get 30, 40, 50% of your power supplied from that generator and reduce your load that much to participate in the programs. The third category is those folks who combine both of those activities, generator and curtailment at the same time, to have that reduction. So yes, hospitals are typically a good fit for this program, and can earn significant revenue. I know one of my hospital sites, the hospital that I went to when I had to have my shoulder rebuilt, I couldn't believe how much my hospital bill was, and was very glad to have health insurance. But the amount of money that my health insurance company paid to the hospital was far less than what CPower paid. Okay, I see we have 3 questions that came in as well, so let me hit those. For the energy efficiency projects, how does the validation for the submitted project work? So one, if you have a project that has not been submitted to ComEd, we have one of my colleagues who is a PhD in engineering. I call her Dr. Danielle. She sits in Pittsburgh, and she receives, she basically receives whatever information you have. We need the before and after information. What equipment was there before, what is installed to replace it. And she takes that, performs all the calculations, and does the submittal. We collect the money from the grid, and we pay it back to you. So it's typically if you are in ComEd and can get the ComEd revenue, get that, because it is more than we can get you. They're pulling from two pools of money. But if you've done that process with ComEd, you'll find that the process with us is a lot easier. We do a lot of the work. It's a little less bureaucratic than the ComEd process. I hope that answers that question. Next question. Are there any limits, requirements, timeframes, or payback requirements in order for the project to be eligible for the rebates? Yeah, so still energy efficiency. We can go backwards 1 year to collect the revenue. And then the way the grid pays out for this, it pays out over a 4-year period. So if you have a project that is being completed before this June 1st, we can submit it before June 1st, and then that will create 4 years of revenue payments paid in quarterly increments. So 16 payments for you over the next 4 years for that project. If the project was more than a year ago, you're still eligible, and then but you'd only get 3 years of payment. We can't go back 2 years. I hope that answers that question, but feel free to pop in if I didn't fully answer your question. The third question, what are some of the ways that the organization can reduce their emission to compliance, and what is the return on investment attached to something like this? So I assume you're talking about a generator. These are specific analyses. And so what I think we should do, you start with, I have a list of generator specifications, and I can supply that to you. And then I'll take it back to our engineering team, who will figure out what bucket the generator fits into. And if it does need an upgrade, we can then figure out how much money the site might be able to earn in future years from these programs, and at the same time get a quote from an entity that does this work, does those emission upgrades for generators. If you don't have someone who does this, I know a couple folks who do, and then we can just run a business case for it. Okay. Will these slides be sent to viewers? Sure, I could package these up and send them out. Happy to.